This video will cover the Geometry Regents exam from January 2015, questions 1 through 4. Question 1 says, what is the solution of the system of equations graphed below? And you can see the two equations are written here, but then they are also already graphed for you. In order to find a solution, that means where the graphs intersect. Or in other words, cross each other. So I'm looking for the 2 points where the graphs cross each other. I know it's 2 because I can clearly see that the line and the parabola cross here and here. So what I need to do is to locate the 2 coordinates. It looks like this one over here is to the left 2, down 1, 2, 3, 4. Is it? Nope, that's 3. So left 2, -2, down 3, -3. So that's the first one. Then the second one, I'm going over 2, up 1, 2, 3, 4, 5. So that's 2, 5. Again, 2 solutions because they cross at 2 different points, 2 distinct points. So our answer here should be choice 4. Number 2 says, what are the coordinates of the midpoint of the line segment with endpoints 2, -5, and 8, +3? So there's 2 options here. The first option is to use the formula. We know that the midpoint is equal to x1 plus x2 over 2. So the average of the x values and then the average of the y values. And again, it's a point, so we put parentheses around it. So I'm going to take a second to label my given coordinates as x1, y1, and x2, y2. So then I can just simply plug it in. Unfortunately, this formula is not given to you. The midpoint formula is something that you would have to memorize, but I'll give you a second option that might make things a little bit easier if you don't memorize the formula. So again, our midpoint here, we have 2 plus 8, x1 plus x2, all over 2, comma, -5 plus 3, all over 2. All we have to do from here is just simplify. 2 plus 8 is 10, so 10 over 2, comma, -5 plus 3 is -2 over 2. And again, simplify one more final time. 5, comma, -1, just by simply dividing. So our answer here should be choice 4. And I'll show you how to do option 2, which is actually using a graph. So take a second to turn to the graph paper on the back of your packet here and sketch those 2 given points, 2, -5, 8, +3. Pause the video while you're doing it and then come back and you'll see that I've got the points plotted as well. Okay, so you can see here that I have points A and B. I just chose to call the first one A, the second one B. I plotted them and then I connected them. In order to find the midpoint of this segment, we would need to find the point in the middle of the segment. So what we're going to do is actually make this into a right triangle, because it will allow us to calculate the distance horizontally and vertically between A and B. So horizontally, just count boxes. You should find that you have a distance of 6. Then if you count boxes vertically, you should have a distance of 8. So what we need to do is go to the middle of 6 to the middle of 8 and bring it towards our segment. So the middle of 6 would be move over 3. And the middle of 8 would be move up or down 4. So what I'm going to do is count boxes over 3 and then up 4. Over 1. It's kind of tough for me because I don't have actual graph paper, but if you have boxes, it's nice and easy to count. So we have 1, 2, 3, and then up 4. 1, 2, 3, 4. Perfect. I landed right on my line, and we can see that these coordinates are 1, 2, 3, 4, 5, -1. So again, our midpoint here, M, is located at 5, -1. Again, it's easier if you have actual graph paper. All I did, again, was count the distance between A and B horizontally and vertically by making a right triangle. Then I cut those distances in half because midpoint means it's the halfway point. So for this page, answers should be the following. Number 1 is choice 4, and number 2 is choice 4 as well. Number 3 says, as shown in the diagram below, when hexagon ABCDEF is reflected over line M, the image is hexagon A prime, B prime, C prime, D prime, E prime, F prime. So what we did here again was just take this original figure and reflect it to map on top of a figure 2. It says, under the transformation, which property is not preserved? So we're going to come up with 3 true statements and then one that's false. In a reflection, we know that a reflection preserves distance. That means the length of the sides are the same. So AB is congruent to A prime, B prime. Side lengths stay the same. It also preserves angle measure. This angle A is congruent to angle A prime. Additionally, the area and perimeter is preserved. However big the area of ABCDEF is, the same area is on the other side, A prime, B prime, blah, 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 because the distance was preserved. The one thing that a line reflection does not preserve is orientation. And I'll talk to you about what that word means. Orientation is the order of the letters. So for example, if I start with A on the the hexagon ABCDEF, and I read clockwise, it reads as A prime or A B C D E F. Again, clockwise A B C D E F. If I start again with A prime and still read clockwise, on my new figure, the image, I end up reading it as A prime, F prime, E prime, D prime, C prime, B prime. The order of the letters is vastly different than the original picture. We both start with A, but then the second letter is different, the third letter is different, and so on and so forth, which means that orientation, the order of the letters, is not preserved. So again, answer here should be choice 3. Number 4 says, in the diagram of triangle ABC below, segment BD is drawn to side AC. If the measure of angle A is 35 degrees, notice that I'm labeling as we go, and the measure of angle ABD is 25. So A to B to D is 25. And the measure of angle C is 60. What type of triangle is triangle BDC? So I'm just going to take a second to outline that triangle because that's the one we care about. So my first step is to figure out this angle here, angle ADB. My reason for finding that angle first is because I noticed that I have this triangle, ADB, where 2 angles are already given, 35 degrees, 25 degrees, and say X. So what I can do is remember that 3 angles in a triangle sum to 180. 35 plus 25 plus X equals 180. 35 and 25 sum to 60. Solving for X, we find that it's 120 degrees. So this angle, ADB, is 120 degrees. My next step is to use the fact that we have a straight line here. Angle ADC is a straight line. So here I know that I have 120 on the left side and say Y on the right side. We know that 2 angles on a straight line also sum to 180 degrees. 120 plus Y equals 180. So solving for Y gives us 60. So that means that this angle BDC is 60 degrees because it's adjacent and supplementary to angle ADB. Now my last and final step is to solve for the third angle in triangle BDC. Right now we have 60, 60, and say Z. Again, 3 angles in a triangle sum to 180, so we have 60 plus Z equals 180. 120 plus Z equals 180. So solving for Z, we find that Z is equal to 60. So now again, the question was, what type of triangle is BDC? If all angles are 60, then the triangle must be equilateral. And this is because an equilateral triangle has 3 congruent angles. If we were to look at scalene, scalene has no congruent angles. Obtuse has an angle greater than 90. And a right triangle, of course, has an angle equal to 90. So again, the only plausible choice here is equilateral, where 3 angles are congruent.